Tennessee's at-home learning series for math. Today's lesson is for all fifth graders out there, though all students are more than welcome to tune in. This is the 17th lesson in our series. My name is Miss Williamson, and I'm a fifth grade teacher in Tennessee School. I am so excited to be your teacher today for this lesson. Welcome to my virtual classroom. If you haven't seen our previous lessons, you can find them at the Tennessee Department of Education website, www.tn.gov/education. You can still tune into today's lesson if you haven't seen any of the others, but it might be more fun if you go back and watch the others first, as we'll be building on what we've learned previously. Today, we'll be learning about volume as an attribute of a solid and understanding concepts of volume measurement in order to measure the volume of rectangular prisms. To fully participate in today's lesson, you will need paper, pencil, and a surface to write on, or you can find the student packet for Grade 5 Math, Lesson 17 at www.tn.gov/education. I'll give you a moment to get your things gathered. In our previous lesson, we learned about using unit cubes to construct solid figures that have length, width, and height. Today, we will continue working with solid figures as we think about volume. When you hear the word volume, what do you think of? Interesting. I heard some of you say volume means how loud the sound is. Volume can also mean the amount of space inside of a rectangular prism. Think about a packing box. If I wanted to know the amount of space inside of a packing box, I'd be finding the volume. Now, look at this box I have here. In mathematics, when we think about volume, we want to know how much space the solid occupies. Volume is measured in cubic units. Remember in our last lesson, we discussed the difference between cubic units and square units. Square units are two-dimensional. They have two dimensions, length and width. Cubic units have three. When we measure volume, we measure it in cubic units. So we need to know how much space is inside this box. If we wanted to know how much space was inside this box, we would do that by measuring its cubic volume. So how could we use unit cubes to find the volume of a box like this? You're right. We could start by filling the box with the cubes to see how many fit without any space or overlapping. So look here. I've already fit in 1, 2, 3, 4, 5, 6, 7, 14, 21, 24 unit cubes. But I have more room, I have more space, so I would need to continue filling this box with unit cubes in order to find the volume. The total amount of unit cubes it took to fill the box would tell us the cubic volume of the box. Now let's look at this rectangular prism. So what I did is I have the 2D representation, and I also built this prism with cubes. How many unit cubes are used to make this rectangular prism? Yes, there are 8 unit cubes to make this rectangular prism. Let's count those. 1, 2, 3, 4 in our front layer, 5, 6, 7, 8 in our back layer. Excellent work. So what's another way that we could have found the volume of this rectangular prism? Good. I heard somebody say, Miss Williamson, I could have thought about the front layer having 4 like you did, but instead of doing 4 plus 4, I could have said 4 times 2, because there are 2 of those layers, to give me a volume of 8 cubic units. Well done. Remember that volume is the measure of the amount of space that a solid figure occupies. Volume is measured in cubic units. How can we use cubic units to find the volume of this rectangular prism? Those are some good suggestions. You're right. We could count up all the cubes to figure out how many 1 centimeter cubes are inside to find the volume. But what might happen while I'm counting up all the cubes in this figure? You're right. I might lose track of how many there are, and I might make an error. Instead, we can use information from the problem to help us find the volume. First, we need to know how many unit cubes are in the bottom layer or the base of the rectangular prism. I want you to listen to that word. Base is a word we're going to use a lot. When we say the base of the rectangular prism, we're using that meaning the bottom of the rectangular prism. That's something you're going to want to commit to memory. It's so important when we're dealing with volume. Okay, so the first thing we need to do is we need to know how many cubes make up the bottom or the base of this prism. In other words, I want to know how many cubes are on this bottom layer. Remember, not all the cubes are visible, but they still need to be counted. So how can we use what we can see to help us figure out the volume or the total amount of cubes in the bottom layer? Excellent idea. I heard somebody say, well, we know there are 5 cubes in the length, and we know that those cubes are in 4 rows. So I can use multiplication. 5 times 7, or my length, times my width, gave me, what's 5 times 7? What's the product of 5 and 7? That's right, 35. So we know the bottom layer is made up of how many unit cubes? That's right, the bottom layer has 35 unit cubes. This prism, though, is made up of how many layers of 35? That's right. This prism is made up of 3 layers of these unit cubes. I see it. 1, 2, 3. So the number of unit cubes in each layer is the same every single time. And so what can I do to find the volume of the entire figure? Okay, that's right. I can take 35 cubes make up the bottom layer, and that there are 3 layers, so I can multiply to find the total volume. What is 35 times 3? 105. And so I would say this figure has a volume of 105 cubic centimeters. Why do I say cubic centimeters? I say cubic centimeters because remember, I'm counting the number of cubes that would fit or make up this figure. Excellent work. Let's do a similar problem. Are you ready? How can we use the information provided in this diagram to help us find the volume of this rectangular prism? Yes, you're right. I can find the number of unit cubes in my base or the bottom, and I can multiply that by the number of layers that make up its height. And then I can write that volume in cubic units. So the first thing we need to do is find out how many cubic units make up our the bottom of our prism or the base. How many unit cubes do you think are in the base of the prism? Okay, so I notice there are 5 unit cubes from side to side from in the length. I notice there are 3 rows back or 3 unit cubes back. So even though I can't see everything under here, I can conclude that the bottom layer is made up of 15 unit cubes. Do you agree? Great. Now, if I know the base is 15 unit cubes, remind me what I do to find the volume of the entire figure. Yes, I need to use the height. I know 15 is stacked up how many times? 3. So what's the height of our prism? 3. So to find, we use multiplication to find the total number of cubes in this prism, 15 cubes per layer times the height or the number of layers is 3, gives me a volume of 45 feet cubed. You notice I wrote a 3. That means cubed. I also could have said 45 unit. It's made up of 45 unit cubes. I also could have said it's 45 cubic units. Those are all ways of describing volume. How is multiplication helping us to find the volume of these prisms? Good point. By finding the number of unit cubes that it takes to fill the base of our rectangular prism, and then counting the number of repeated layers in our prism, we can multiply the equal sets of cubes from the layers by the height, and that's giving us the volume of our rectangular prism. Let's look at some more examples together. To find the volume of this rectangular prism, we first need to know the number of unit cubes in the base of this prism. How many unit cubes are in the base of the base of this prism? Yes, you're right. There are 4 unit cubes that make up the length, and those go back in 4 rows. So my length was 4, my width was 4 to give me a base. The base is made up of 16 unit cubes. That's right. Now, when I'm looking at only the base, I remember the base is still three-dimensional. It just only when I'm looking just at that bottom layer, what's the height of that bottom layer? That's right. That bottom layer is only made up of 1 unit cube. So now we're going to use multiplication to find the volume of the entire figure. How do I do that? You're right. I count up the number of layers in the prism. Can you count the layers with me? 1, 2, 3 layers. I noticed that that layer is matching that 3 over to the side for the height. Did you make that observation? So we know that this prism has 3 layers. So how can we find the total number of unit cubes to fill the prism? You're right, we will need to multiply the number of layers, which was 3, by the number of cubes in each layer. Can you write an equation to match what we would do to solve that? Did you say 16 cubes in each layer times 3 layers gives us 48 unit cubes? Excellent work. So we could say this this rectangular prism, has a volume of 48 cubic centimeters. Here's a similar problem. Continue working along with me. You guys are doing great. To find the volume, we need to know the number of unit cubes where? Did you say in the base? You're following along phenomenally. All right, how many unit cubes make up the base of this rectangular prism? You're right, there are 12 because there's 3 unit cubes back and 4 unit cubes from side to side. So we could say our length is 4, our width is 3, and so 4 cubes in 3 rows back gives us a base of 12 unit cubes. Now, what's the next step to finding the volume of the entire prism? That's right. We need to count the number of layers that make the height of this prism. Let's count. Can you count the number of layers with me? 1 layer, 2, 3, 4, 5. 5 layers. I'm noticing again a connection to the height dimension. And so, if there are 5 layers of 12, what would we do to find the total number of unit cubes? You're right. We need to multiply the number of layers, which was 5, by the number of unit cubes in each layer, that was 12. And so 12 cubes in each layer times 5 layers equals how many unit cubes in the entire rectangular prism? That's right. There are 60 unit cubes that make up this prism. And so if there are 60 unit cubes in this prism, what would we say the volume of the prism is? Yes, the volume is 60 cubic centimeters. And you'll notice here I wrote unit cubes. Those unit cubes, though, are what dimensions and for this problem. You're right, we're using the unit centimeters. Excellent work. Now, it's your turn to solve. I know you're ready. I know you've been paying good attention. I am so proud of you. Keep it up. After you've had a few minutes to work, we'll come back together and we'll check it. All right, great. Here is your problem. Can you find the volume of this rectangular prism? Good job. Keep going. You have about 30 seconds. All right. Are you ready to check your work? Great. Did you find the number of unit cubes in the base? Excellent. Did you multiply 4 times 4 because the length is 4 and the width is 4? So we have 4 cubes in 4 rows to give us 16 cubes. Did you get 16 for your base? Excellent. Now, when we look at the base, what was the height of just the base? You're right. When we look just at the base, it's only 1 layer. But now what did you do next? Did you find the height of the prism? Great. Did you notice that the height of the prism was 3 centimeters? And did you then multiply the number of unit cubes in the bottom layer or the base times the number of layers? So 16 cubes in the bottom layer times 3 layers. And did you get the volume of, did you say it was made up of 48 unit cubes? Excellent work. And so if it's made up of 48 unit cubes, what's the volume of this figure? It is 48 cubic centimeters because our unit cubes are centimeters. Great work, everyone. Are you ready for another one? I'm sure you are. I'm going to give you about 2 minutes again. Can you find the volume of this rectangular prism? Keep it up. You've got about 30 seconds. Are you ready? Let's begin. Did you start by finding the number of cubes in your base? The base was 2 cubes long and 3 cubes wide to make up how many cubes in the base? Did you say 6 cubes make up the base? Did you then say that that base was stacked how many times? Did you say the height or the number of layers was 3? Excellent work. So 6 cubes in the bottom layer times 3 layers of 6 gives us a volume of 18 unit cubes. So this figure is made up of 18 unit cubes. If I were to decompose and take this all apart, I would end up with 18 of these little cubes. And so then we would say the volume is 18 cubic centimeters. What do you think would happen if I was measuring in feet instead of centimeters? What if I changed my unit from centimeters to feet? How would that change this problem? Brainstorm for a moment. I heard the only thing that would change is that instead of cubic centimeters, we would represent it in cubic feet. That is phenomenal. You're right. Because all that would mean is that the boxes or the cubes we're packing into our box would be feet instead of centimeters. Good job. All right, I think we have time for one more. Are you ready? Can you find the volume of this figure? Good work, guys. Keep it up. You've got about 30 more seconds. Okay, are you ready? Did you start by finding the number of cubes in the bottom layer? There are 6 cubes. The length is 6 cubes long. The width is 5 cubes front to back. And so there's 5 layers of the 6 cubes to give us how many cubes in your base? That's right. There are 30 cubes in the base. What was the next step that we had to take? You're right. We needed to know how many times, how many layers of 30 were stacked up. How many layers of 30 did you get? Phenomenal. Did you say 3 layers? Once again, we're noticing the number of layers is matching that third dimension or our height. So did you do 30 cubes in the bottom layer times 3 layers of cubes gave us a total of 90 unit cubes in this figure. Or we could say it has a volume of 90 centimeters cubed. Great work. I have one more question for you. Is this the only figure that could have a volume of 90 cubic centimeters? I hope some of you said no, and we recall from our last lesson that there are multiple prisms that can have the same volume. How do I get the same volume but the prism looks different. Excellent work. You're right. I can change the height or the length or the width. For instance, what happens if I would have half the length and got 3, but I doubled the width and made it 10? Does the base still going to be made up of 30 unit cubes? It sure is. So let's keep that in mind. Not all prisms with 90 cubic units are going to look the same. You have done a great job today. I am so proud of you. We've reviewed using multiplication to determine the volume of rectangular prisms with a focus on counting both the number of cubes in each layer and the number of layers. You did a great job. After the video, you will have some problems to practice on your own. I will show you your independent practice problems now. You can also find these practice problems at www.tn.gov/education. Good luck on your independent practice and do your best. Let me zoom out. I'm sorry, I didn't realize you couldn't see them all. There we go. I have enjoyed reviewing visual representations of unit cubes to determine the volume of rectangular prisms, focusing on counting the number of cubes in the base and then using the number of layers in the base to help us find the volume. Thank you for inviting me into your home. I look forward to seeing you in the next lesson in the Tennessee's at Home Learning Series. Bye, guys.